So in the last couple of videos, we talked about what radians are, where are the common radian angle measures on a unit circle, and what are those ordered pairs for those radian measures. But we really haven't talked about what they mean and why do we even care. All right. So in today's lesson, we're going to go through and figure out why is the unit circle important and how does that relate to sine, cosine, and tangent angles. So let's take a look first at one of the common angles here. This is going to be basically at 30 degrees. And I'm going to talk about this in degrees and then we'll talk about it in radians. So this right here, 30 degrees, and we went through this triangle here that we wanted memorized, where the hypotenuse was 1, the long leg there was square root of 3 over 2, and the short leg was 1/2, and that's exactly what I've got going on right here, 1/1/2, and square root of 3 over 2. And we said in that last video that at that point right there, if we pretend like that's the origin, we go over root 3 over 2 and up 1/2. So root 3 over 2, comma 1/2, and that's an ordered pair for that spot. But it means nothing to us until we see what's going on here. I want to remind you that this is a right triangle, so we can apply right triangle trigonometry to it. And I just want you to figure out the sine of 30 based on that triangle right there. So if you've paused the video and given that a try, let's look at it without a calculator. Just say the sine of 30 degrees is equal to the opposite over the hypotenuse. The opposite side is 1/2 and the hypotenuse is 1. So 1/2 over 1. Well, 1/2 over 1 is 1/2. So the sine of 30 is equal to 1/2. All right, let's look at another one. Let's try doing the cosine of 30 degrees. So pause the video, give that a try. So I take it you paused it. The cosine of 30 equals adjacent over hypotenuse. Well, in reference to the 30-degree angle, the adjacent side is root 3 over 2, and I'm going to divide it by the hypotenuse. The hypotenuse here is 1. So root 3 over 2 divided by 1 is root 3 over 2. That equals the cosine of 30. That's interesting. These two values here, the cosine value and the sine value, which came out to be 1/2 here, is exactly what's written right here. Notice that this is the cosine of 30 and this is the sine of 30. And so here's where it all comes together. Notice the reason why this works the way it does is because of the hypotenuse being 1. Remember that the sine of any angle, theta, equals the opposite over the hypotenuse, and the cosine of any angle is equal to the adjacent over the hypotenuse. In both cases, our hypotenuse is 1. In fact, if we look at the unit circle that we drew, remember that the radius is 1 going all the way around. So no matter where I put these triangles, whether it's right here, or right here, or if I have another one right here, all the way around, the radius is 1. So when I start taking the opposite over the hypotenuse or the adjacent over the hypotenuse, it's going to be dividing it by 1 each time. And so all the way around the circle, if I'm talking about the opposite side over the hypotenuse, it's just going to equal the opposite side. If I talk about the adjacent side over the hypotenuse, it's just going to equal the adjacent side. So when I start to look from the last video at these ordered pairs that I put around, we can say that the x-coordinate is equal to the cosine of theta, and that the y-coordinate equals the sine of theta. So if you can produce this unit circle right here, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 angles that you can tell me the sine and the cosine of just by looking at the ordered pair. And if you forget which one's which, notice that they're in alphabetical order. X comes before Y, and C comes before S. So know that X always pairs with cosine, Y always pairs with sine because of the alphabet there. That helps some students remember when they start looking at these ordered pairs and saying which one's which, put them in alphabetical order. So cosine and then sine there, just like X and Y. Okay? So that kind of clears up, hopefully for you, why did we learn this? It's so I can quickly tell you what the sine and cosine of all these different angles are. That includes if they're in radians. So if I say, what is the cosine of pi over 4, you can say, okay, that's going to be the x-coordinate there, and you should visualize that blue triangle I had. The cosine of pi over 4 is just square root of 2 over 2. And I'm going to take you through some drills so that you can start to quickly pick up on these. These videos right now are just the explanation of why it works. And then I'll probably make a few videos where we say, hey, let me take you through my thought process of how I quickly come up with the sine and cosine values and tangent values as we go around. Now there's one more trig function we need to look at, and that is the tangent function. So I want to know what values, by the unit circle here, how can I come up with tangent values? So let's take a look and just a reminder of what tangent means. I want you to recall that tangent means opposite over adjacent. And that's where I'm going to start you off with on this one right here. If we say that the tangent of, and we'll use the 30-degree example again, the tangent of 30 is equal to the opposite over the adjacent, that's going to put us using the opposite side over the adjacent side. So I'm going to say the opposite side is 1/2, the adjacent side is root 3 over 2. And I'm going to simplify this right here. 1/2 divided by root 3 over 2. So I'm going to keep that first one 1/2, change the multiplication, and flip that other fraction 2 over square root of 3. And when I multiply these out, these cancel, and I get 1 over square root of 3. I want my students to rationalize these, so I'm going to rationalize it by saying multiply by root 3 over root 3, which gives me root 3 over 3 itself. So the tangent of 30 degrees is equal to square root of 3 over 3. All right? Another way we can say that is, notice what the opposite side is in this case, okay? Because this is something that's kind of key for when we're talking about trigonometry. It's one of our first identities we learn, is what's going on here. We are taking the opposite side and putting it over the adjacent side. So if I look back at this, the opposite side we just said was the sine of 30 degrees. The adjacent side was the cosine of 30 degrees. So when I put opposite over adjacent, what I'm really doing is I'm putting the sine of 30 over the cosine of 30, and I'm saying that equals the tangent of 30. And this breaks us down to our first trig identity we're going to learn this year, and that is that the tangent of theta equals sine over cosine. We'll learn more about these later. This is more just kind of like a hint. If you get it now, great. If you don't, we'll talk about it in upcoming videos. But that's where it stems from. Right there is a nice way to describe it. Either way, we know that the tangent of 30 equals root 3 over 3. And we'll get more into this as we talk about it. Let's go ahead and write that down on our unit circle. These things fill up so fast, it's hard to write something down pretty much anywhere. So I'm just going to write it on the inside track here. If you look in the description, I will post that link to where I typically have students fill it out on something that looks like this right here. It's just, I can't, if I write in markers, it just looks like a blob of mess. And so I kind of try to keep it in the larger circle that I have here. But we go through and we'll write down the tangent value in each box there. But the key there does go back to this right here, sine divided by cosine. Remember that we said that sine equals your y value and cosine is your x value on those ordered pairs. So as you go around the circle to write down the tangent values, just take y and divide it by x here. So we just did that with this one, and we said that was, what did we say it was? We said it was, what, root 3 over 3. So that goes right here. That's this line. Its tangent is root 3 over 3. On this one, if you take square root of 2 and divide it by square root of 2, you get 1. So the tangent of 45 degrees, or pi over 4, is 1. On this one, we're going to take square root of 3 and divide it by 1/2. Let's do that together on a piece of paper. Square root of 3 over 2 and divide it by 1/2. Root 3 over 2 divided by 1/2 is equal to root 3 over 2 times 2 over 1, which equals root 3. So that is our tangent value right here. root 3. If we look at our quadrant angle, 1 divided by 0, you can't do that. That is undefined. Can't divide by 0. But over here, we can divide 0 by 1, and we get 0. So written here in periwinkle is our tangent values. 0, root 3 over 3, 1, root 3, and undefined. And here's where I'm going to stop you, and I don't want you, once again, just going through and memorizing these. I don't even want you going through and dividing these out every time. It's not that complicated, okay? It is when we develop it. I want you to understand where it comes from. We're taking y and dividing by x, or sine divided by cosine. But when it all comes down to it, there are 4 that you need to know, okay? Sorry, 5 that you need to know. When we're talking about tangent values on the unit circle, you basically have 5 options. You can have root 3 over 3. You can have 1, you can have 0, you can have root 3, and you can have undefined. Those are your options for tangent going around the unit circle. Now I want you to pause the video and put these in order from least to greatest. Now undefined doesn't have a value, but put these 4 in order from least to greatest. I take it that you actually did what I said. You pause the video, put them in order from least to greatest. Let's take a look at what you got. If you're doing this and you need a calculator, that's totally cool. I need a calculator too. The square root of 3 is what we want. Well, the square root of 3, if you punch it in, is 1.73. Now, that value may help you, it may not, but the key thing about this is that you should notice that 1.73 is bigger than 1. If I divide it by 3, I get 0.57. That tells me the value of root 3 divided by 3, and the key thing there is that it is less than 1. So now I can put these in order pretty simply. I know that 0 is the smallest, and then I'm going to have root 3 over 3. Then I'm going to have 1, and then root 3. And then undefined is kind of out here. It doesn't belong there because you can't compare it to something else. But these are now in order, and that's very important when we start to look at this unit circle here. Because what I want you to think about now is, instead of thinking about this as sine over cosine, I now want you to think about tangent as slope. So if I look at this and I rise to this point right here, I've risen 1/2. And then I run this distance, which is square root of 3 over 2. My slope is rise over run, which is exactly what I do when I do this whole sine divided by cosine thing. Rise is my sine value. My run is square root of 3 over 2. So 1/2 divided by root 3 over 2, not only is it my tangent, it's my slope of this line. Let me say that again. The slope of this line is the same thing as tangent. Go around and check that. What's the slope of this horizontal line? It's 0. What's the slope of this line in the middle? Well, you rise root 2 over 2, you run root 2 over 2. So the slope of this line is 1. What's the slope of this vertical line right here? Well, that vertical line, anytime you're going back to algebra, the slope of a vertical line is undefined. So if you know these values right here, we can quickly come up with the tangent by thinking of it as slope. Slope is 0, slope is 1, slope is undefined. The only two that kind of throw off students are these two right here, root 3 and root 3 over 3. So if you got those two memorized, like you know that tangent value could be root 3, it could be root 3 over 3, think about which one is bigger. Now we used a calculator. You don't need a calculator to figure out that root 3 is bigger than root 3 divided by 3, okay? If you divide something by 3, it's going to be a smaller number. So root 3 is larger. The next thing I want you to think about is larger slopes are steeper. So if I'm looking at this right here, this is a steeper slope because root 3 is larger than root 3 over 3. So once you get these values down, notice the slopes here are positive, so our values are positive for tangent. Once we go over here, we can use these same values for tangent to fill out quadrant 2. We have those same options. That's going to be undefined. This one's going to be 0. This slope, remember, it's negative root 2 over 2 and root 2 over 2. It's going to be 1 as well, except for it's a negative slope, so it's going to be negative 1. Then look at our two remaining ones at 2 pi over 3 and 5 pi over 6. This one is steeper, so it's going to be our root 3. But because it's a negative slope, it's got to have a negative out front. If you forget, you can always say sine divided by cosine here. But I think once students understand the slope concept to tangent, it makes it a lot easier. Make sure that negative, by the way, is on the outside of the radical. Sometimes I see it on quizzes and tests, they put it on the inside, and then it becomes imaginary, and we can't have that. You get it wrong. So the negative goes on the outside. And then lastly, this is the more shallow option here, and it's going to be root 3 divided by 3. Make sure it's negative. As we go into quadrant 3 to fill it out, our tangent here has got to be 1. That's our one slicing right through the middle. It is positive because it's going uphill. This is the steeper slope when I compare it to this one right here. So this is going to be my root 3. It is a positive slope, so we leave it positive. And then this is root 3 over 3. Remember what all this means. It means that the tangent of 7 pi over 6 is root 3 over 3. Now, at the bottom here, what's the slope of this line? It's undefined, so the tangent of 3 pi over 2 is undefined. That takes us to the fourth quadrant. There are only 3 more angles to fill out for tangent. This one right here is in the middle. Remember, it's negative root 2 over 2 divided by root 2 over 2. That's going to give me a negative 1. And then compare these two on these 30, 60, 90 triangles. This one is a steeper slope. It's going to be my negative root 3. This one is my more shallow one. It's going to be negative root 3 over 3. Another thing that can help you maybe to double check things, especially if you get confused with which one's steeper, is if I draw a line. Let me highlight this line right here. I'll zoom out. And I'm going to trace this one out right here. So here is, and that didn't really, I don't feel like that took very well. Let me highlight it. Grab a highlighter. That's a little better. Notice that this line, because it is a line, it should have the same slope everywhere, and it does. It's negative root 3, whether it's in quadrant 2 or quadrant 4 here. Same thing with this one. This one is positive root 3, and notice both in quadrant 1 and in quadrant 3, it is positive root 3 there. You can go all the way around the circle and match them up. 0 here, go straight across 0, root 3 over 3, root 3 over 3. They match up because it's the same line, all right? Tangent is the slope of those lines. You can look at it that way. You can look at tangent as sine divided by cosine and go with it that way. Either way, I hope in this video you learned something. I hope you learned that the ordered pairs there are cosine and sine, and that tangent is the ratio of that, sine divided by cosine. Or more importantly, the slope. Because I think if you learn those key values for tangent, think about it in terms of slope. I know students that take it right into calculus, and it helps them quickly come up with those values. That's the why behind everything. So I try to go in depth with explaining why it works and some tricks on how to learn them. In the following videos, I'm going to do some where we just say, what's the sine of pi over 4? And you can quickly come up with it. What's the tangent of 3 pi over 2? Quickly come up with it. We're going to take and start to really apply this stuff. But for an introduction, I think we need to go in depth so that as we do our practice, you have something to kind of fall back on. Okay? Thanks for watching. Thanks for working hard. And I hope you're having a great day.